Okay, so 6th hour again, taping. Some jibber jabbers over there. Yeah. Zoom in a little bit. Okay, and then group number 3 you got picked. What kind of subject matter is this? So is this pre-calculus? Is this algebra 2, geometry, algebra 1? What are we dealing with there, group 3? Geometry. Okay, so the reason I start off with that, and I'm holding the book in class, everyone look over here. Okay, in the front cover, you have to have the hard book cover though. I don't have this online if this didn't get scanned. There are formulas. Actually, this front part is algebra 2 stuff that you did last year. Some special factoring cases, I believe, and some other things that you may or may not have done. But then the next page is geometry. So, I told you how chapter 1 works. It's very scatterbrained. Yesterday you did like some quadratics, and by the way, remind me at the end of the notes to cover some of the homework, and then I'll collect it. But you did solve some quadratics, and now all of a sudden we're doing geometry, and then we're going to be doing linear situations, and then we're going to be solving with a graphing calculator, all in one. Are those related at all, really? No. Okay, so you just got to get used to it. All right, so group number 1, you said geometry. And I assume everyone read, because I told you to. If you didn't, you're anti-educational in nature. All right? And you will fail. All right, so what kind of geometry? Like, what would be the subject of the geometry? Like, what concept geometrically within U3? And I'll pause the video and let you think about it. Volume. Did you hear that? Yeah. Sorry. Now, what is the picture of the first cake? That will be group 3 again. I will pick another group for what the picture of the second cake is. Rectangular prism, first one. Cylinder, the second one. Now, I'm going to say this right now. Right now. The CAT student fails the one that does nothing on a question like this. Okay? If you sit there and read it and say, I don't know how to get the answer right away, I quit, you're done. It's over. Hasta la vista. Good night, Irene. And all the other things that people say when the situation is destroyed. So, what you do is you make a drawing. And by the way, why is this X here? Why is this X here for the height? Because I don't know it. Okay, so the next question is what is the volume of a rectangular? Group number 2 got it right away. Length times width times height. I'm going to stop there before I start throwing numbers in here. So this is what you need to do, and this is 2-year-old stuff. So again, you can't sit there and do nothing. I showed you the front cover of your book. You look at that and you try to figure things out. Otherwise you fail. All right? Next thing. So big B times H is the volume formula in general for prisms and cylinders. And the area of the base is a circle. By the way, what's the area of a circle? That 2 pi r, that's what? Circumference. It's pi r what? Squared. R. What's listed up here? Not r, but what? D. Because that makes me infinitely sad. The non-thinkers who just shove stuff, and I forgot to ask this before I revealed it. So I already revealed it. But just shove numbers and formulas. 8's a diameter. You need the radius. Okay, what did I accidentally reveal? I revealed that the height is what? What did I reveal as the height? 2x. Why? What's said in the question? The height of the second cake is twice. And I don't know what it is, so that's why I write 2x. And again, the CAT student doesn't do nothing. I don't care if that's a double negative. The CAT student does something. Okay, so I have 2 of my 3 things for a rectangular prism, and I plug it in at length with height. Wait a minute, I have an x. Oh, I still don't really have anything. All right, let me go to the cylinder. Pi r squared times height. And the height in this case is 2x, so you just substitute that in. Then, okay, I don't really have any information until I simplify. Now what I do is I do 4 squared times pi, and then I get that 2 over with this stuff. So now I have 2 expressions with x in them now. And now I can compare. which cake has more cake? Which cake, no matter what, is going to have more cake? The rectangular, because it doesn't matter what x is. If I double x, well, that's already incorporated into this. So now I got this in terms of x. Whatever x is, this volume is going to, that x is going to be multiplied by 117 as opposed to only 100.5. So if you care about more cake and the price is the same between these two, get the more cake. Serve more slices for people. You all right? All right. Now, here we go again. Just pay attention. Pay attention. So, up there at the top of this little chart question, which is number 24, is the number of revenue passengers enplaned. What does that mean? They flew in a plane. It's the weirdest word I've ever seen. Okay, in a 14-year period. Okay, so here's the idea. And then I'm going to actually build this up and make up another word problem on tape. Talk about Mr. Samuelis' salaries. You look at this chart of data, and then last year I did teach how to put this in a graphing calculator. I'm going to wait. I'm going to wait till we get more knowledge of other different types of functions, and then try to put it together in one day, and then inspire people with inspires and 84s with 84s, and then try to get this figured out in a worksheet format. For right now, you're going to do this by hand on your paper. So you look at this data, and by the way, we should get used to doing this. Make year 1991 year what? Year 1. Okay, it's not on the chart. Think about it. What does that make year 2010 then? What would year 2010 be if this is year 1, 1991? Think about it. It'd be year what? 20. All right, I always think it's smart if you simplify the years to just make it year whatever. You wouldn't want to make this year 0 because then it's hard to think what's 2010. I like them to end the same. So 2010 is year 20. Smart. All right, last hour we came into a problem when I did my salary question. But what you could do is graph this. All right, so this is how you do it on a graphing calculator. I'm not going to show you that yet. It's really not that hard, but what you should do, though, is make the x's 1, and then what should you do for the y's? What do we put on the y-axis? We've talked about this. I just did it with my thing here. You make it a little, the dash thing, the squiggly thing. And that just says the y-axis we're starting at, what was it, like 400 whatever? And then 452. Now, what do you think you should make the y's go by? It goes from 450 to almost 700. So what do you think the tick mark should be on your y-axis? Go by what? 20s might be okay. I think still that's a lot of work. I'd go even further and do what? Maybe 50s. And I'd probably stop there. So make 50 tick mark, 450, 500, 550, 600, 657. That's still a lot of tick marks, right? If you went by 20s, you'd have a lot. 5 times as much. No, that's not right. I was never good at math. Anyway, what happened? This all looks what? Up to here. What does it look like? Line. And then what happens? Bloop. Does anyone know what happened? 9/11. Boom shakalaka. You got it right away. Look at where the data blipped. 2000, 66666. 0.1, we're okay. Public school anyway, we're fine. And then 2001, 622. Oh no. And then look at it's even worse. And I'll tell you historically, you guys were all about 1, 2, or 3 years old when this happened. The actual airlines were shut down for 3 weeks to a month. 0 flights. None. Just imagine that. And then we got back, and then why was 2002 so bad? We were scared. People did not want to fly anymore because there was a major disruption in our lives. So anyway, that's what the blip in the data. But then look at it again. What does it look like is happening with this data after a few more years? If I draw a line through here, what does it look like is happening? It's starting to what? Come back into the average of what happened before. So this was an emotional blip. All right? And then as our emotions got more confident and we felt we were safe, then things started coming back together. But anyway, a little history and math, cross-curricular. I'd like to do that. Now look at what they actually physically ask you to do. And this is why you don't need your graphing calculator. And this is the idea. And this is what makes me mad about students as well after I tell them what you need to do with word problems. Some people read the first 3 words and quit. I'm tired. Okay? From 1991 to 2000, the data seemed to follow a linear model. We just talked about that. Everything uninterrupted. Use the 91 and 2000 points to find an equation of a line. And then superimpose it on your scatter plot. So what do you do in this word problem? You extract the coordinates. How many coordinates make a line? 2. So that's all you need is 2 data points, and they tell you which 2 to use. So remember what I did with 91? I made that year 1. Year 1 equals 452.3 million people emplaned. And then 2000 is actually year 10, and that's easy to figure out. 10 comma, that bad number close. All right. What do you find next? What do you find next from these data points? Slope. I'll just throw that stuff up here, then I'll stop and let you take it down. Okay, but as you're taking this down, look at what I get for the slope, and then we'll talk about, I'll slow it down here for you. What does that slope mean? And that's what I'll say after I start the movie up again, or ask. We got to be able to do 2 things at once. I forgot to say the whole idea of when I say domain, you say what? What goes with domain usually? Range. Or someone said X. I like that. I was doing an opposite thing. You were doing an exact thing of what's the same. Domain is X. Range is Y. Input is, come on, which letter? No, input is X. Domain. Output is what? Independent is who? Dependent is, now we're going to talk about this in a sentence that makes sense. The amount of passengers that were emplaned depends upon, anyone? The year that I look at on the charts. So there's a domain, range, independent, dependent sentence. Y, the amount of passengers is the Y, and the years is the X. Independent, dependent. And then you can go ahead and do this. Now, the students I had last year, we did go to the graphing calculator. And we did plot the points. But what you could also do is, without plotting the points, we could answer the next question with a graphing calculator. You could go to the Y1 screen and type this in. And by the way, not to go over this too fast, but there's your equation of a line again. You're just tested on that. You'll be tested on it again. And then plugging in one of the 2 points for point slope form. I picked the 1991 point. X minus year 1, Y minus how many people were emplaned that year. There's the slope. And then we were lazy last year. I didn't even distribute. I just had them add 452 to both sides and then stick this in Y1 for time's sake. Doesn't really take that much time to distribute, but I just thought it was fun. Students like to hear, well, I could be lazy. I could do less. And actually, it's okay if you can. Because now look at the next question. And I'll leave that up there and still try to, my head's in the way, I'm sorry. According to the linear model, in what year did the number of passengers seem destined to reach 900 million? What is that? What is 900 million? Is that X or is that Y? 900 million passengers is X or Y? It's Y. I heard a couple people say X. Just be careful on that. X is the year. Y is how many passengers. So how can I solve this by hand? I could take 900 million and plug it in where? Whoops. Plug it in where? Here. Plug it in where? Y. I put 900 million in for Y, and then I just go through an Algebra 1, very simple solve for X. So even without a graphing calculator, this is very solvable. Everything on this question, there is no need for a graphing calculator. But you could actually put Y1, the equation that I wrote up there, and then in Y2, put Y2 equals 900. And then find the what between these 2 graphs. Intersection. But here's the problem. I think this is the first time we really talked about this in depth. To do that, you actually have to manipulate your windows. Think about X. X is the amount of years. We started with year 1, and this may not happen until year 30. So on your window, look at your calculator. It's right next to the y equals. You can type in these window values. And then, I kind of want you to do that. So I'll show you this equation, then we'll close the video for a second. There's the equation, the first one that I have circled in red, and then put y2 900. Play with the window just so you can see this happen, and then go through the intersect. And then we'll come back to this in a couple minutes. All right, so I walked around the room. Did probably take about 5 minutes to see what was going on. Now what I'm going to do is this. You ready? Got to listen. I'm going to walk around. If you're not listening, you don't write on your paper, I'm going to get mad. I don't know what that means, but all right, so here's another situation I want you to solve. Let's put all Chromebooks away. Already had some nefarious and illegal activities. All right. In 1994, Mr. Samulus made $20,000. Cha-ching. In 2001, Mr. Samulus made $35,000. Mr. Samulus's income pattern is linear. What, if it continues in this linear pattern, would he make in 2010, which was 5 years ago? To taping and unfreeze the screen. Boom. Okay, there it is. Okay, so there's what your equation should have been. How many people used year 4 for 1994? How many people didn't? What did you do? Okay, 1994. Okay, now I got to make a point of this. I used year 4 for 1994. So what do I have to plug in for X for 2010? What do I have to plug in? Do I put 2010, 2010? No, I put, not 11, 20. I put 20 in here. If you put 1994 and 2001 here, then you have to put 2010 in for X. That's the only difference. So you just got to be careful. Now, this blew last hour's mind. Did anyone put year 1 for this? Did anyone put year 1? You did? Did you? Then do you know what 2001 is? It's year 8 is correct. Some people just subtract 2001 minus 1994 and they put year 7. That's wrong. Watch my fingers. You can't do this on the internet. Year 1 is 1994. Look at me. 1994 is year 1. What's year 2? 1995. I'm going to keep doing this. 1996, 97, 98, 99, 2000, 2001. How many fingers do I have? You do not get the just subtracting the years to find out how many years are away from each other. So that's what the problem is. That's why I always, year 1994, I just make it a 4. And then I know 2001 is an 11, and it ends the same number, last digit wise. All right, and then we found out that it made like 54,000. All right, and then the last thing I'm going to do is this. This is a whole long page I'll put online, but I'm just going to ask you one more time to get your calculator out. And I guess I'll do an Inspire on this, because I feel like I do the Inspires less than I do the 84s. So this is what I want you to do, 84s and Inspires. Clear out all your graphs, get them out. Inspires, delete your documents. 84s, just delete your Y1 screen. Close. All right, I'm probably going to have to zoom in a little bit. Sorry, kind of fumbling here. So what we're going to do is we're going to solve this equation. This equation equals 0. I have to tell you what you have to be as a student when you're looking at these things. All right, now, and let's talk about that out loud. I actually have the picture of the 84 off to the right, circled over here. But the 84s, you have to type this in Y1, and the smartest thing for you to do is put Y2 equals 0 and do an intersect. Right? Right? Shh. We just heard that online now, Chief. The shoe comment. Okay, now, let me move this over a little bit. Hopefully, there we go. All right, so I'll do this offline. You don't want to be bored by me typing. For an Inspire, the 0 feature is awesome. So I press enter, and this is the graph. This is what you need to understand as you see this picture. Obviously, one of the zeros stick out. What is that 0 right there, then? Fumble. What is that 0 right here? What is that? It's negative 2, and you can see it right here. X plus 2 is the factor. That means negative 2 is a 0 or x-intercept. But what does it look like is happening here? Is it crossing the x-axis? What do you think? Maybe. It could be doing one of three things. It could be so close to the x-axis but not touching it. Or it could be hitting the x-axis how many times? 2 or once actually is a possibility. So what do you have to do? For an 84, go to your zoom button, which is to right of your y equals. For Inspires, you hit menu, and then you go to window zoom, which we did actually earlier. And then what we're going to do is zoom in. Now listen, 84s. Hit zoom in, and then what you have to do is hit the right arrow. And you got a little blinker, a little crosshair. Do you see it? And you crosshair it all the way to this crazy point that I want to find out what's going on. For an Inspire, I hit zoom in. Oh, for the love of dog. All right. And then I just keep hitting. Hit. And look. How many times is it actually crossing right there? 2. And I got to move my equation. So this is called hidden behavior. It's your job when you see a graph that may be crossing 0 once or twice, that you zoom in and find out actually how many times it's crossing and then actually find it. So for the 84s, you had to put y2 equals 0, and the next thing you're going to do is now find the intersection, and you can find both of them now. How many times do you have to hit enter, 84s? 3. For Inspires, it actually works out better to just analyze the graph and find the 0. Toggle, open, toggle. If you do not zoom in and you go ahead and try to find a 0, you're only going to find one of them. You're not going to find both in both cases. So you have to zoom in on this stuff, and I hope you really understand the importance of that. Analyze graph, 0, boom, open, boom. 2 zeros. 1.9, 2.1. So at the end of your homework, there's these random solve with the graphing calculator. I guarantee you're going to run into this issue, that you're going to have to zoom in and find those zeros. Get the job done. Movie over.